All right, in this video, let's try to take this to the finish line and complete all the rest of the game section functionalities that are missing. So let me switch over to the start game view. And now what I want to do is basically whenever we click any of those buttons, we want to play whatever that move was. And then we also want to be basically calling out our game.js function or functions, which has all the logic for our game, similar to how we used it in our previous project. So we'll be getting the CPU move, we'll be deciding who's the winner, and we're gonna use this next score function, which is basically a helper function that, depending on what the outcome was, it will give you what the new scores are for the player, for the CPU, and for the number of ties. So I'll switch back to my game section here, and let's see what we need to do here. Now, instead of console logging every move when we actually make a move, let's create another function, and we'll call this play round. And what this function will do is that it will receive a move, and when we do call it, we want to get what would the CPU move be. So CPU move equal, and this is where we're going to be calling our functions from the game.js. The function here is get CPU move. Now this function here has an interesting way of operating, where basically it takes an object that can be empty of basically what the difficulty is and what was the player's last move. The reason why it asks for what the last move was is one of the different types of algorithms that it will use. If you choose the difficulty of hard, it tries to increase the bias so that you're beating the last move of the player. So if they did rock, then you kind of assume that the next time they're going to also be selecting rock, so you want to beat that next one. So that's why it needs both of these properties, but as you can see also, we can provide empty values and it will work just fine. So we'll start with the empty values, but it will be your responsibility to complete the rest of this by passing in whatever the last move was and the difficulty level. So here is our CPU move. Next, we're gonna capture who is the winner or what is the outcome of this play here. Outcome equals decide winner, and this here takes the player move as well as the CPU move, and what it would return is one of the following options: either player, CPU, or a tie. Next, we wanted to update our score, and the way we're gonna do that is first create a scores state. So here is my scores object. And the reason why it will be an object, because it will capture both the user score, the CPU score, and the ties. So set score equal use state, where the state is going to be player with a default of 0, CPU with a default of 0, tie with a default of 0. Okay. And so what we need to do here is, once we're done deciding who the winner was and figuring out what the outcome was, we're gonna set the score to be whatever the current score is. We're gonna use that so we can pass it into our helper function, which we have in our game.js function. Again, like I said, it will take whatever the previous score is and the new outcome and figure out what the new object is gonna look like. So here we'll take whatever the previous score was, and we call next score by passing that in, as well as the outcome object. Now let's save this, and we'll go over to our move buttons, and instead of calling console log, we're gonna want to call play round with whatever the player move was or whatever the value of M was. Now if we save that, that should all look fine. One thing that I did notice we're missing is right above the so right below the game header, we actually forgot to include our scoreboard here. Scoreboard has not been included. Now it looks like we also, it's right there. So let's just make sure that we are importing it properly. So import scoreboard from scoreboard. Okay, now Let me switch back to our React version and let's close this for a second. Start the game. Here we go. We get the scoreboard, but let's check what that looks like. All right, so it has a bunch of hard-coded values. So let's replace that with the scores object. And we'll replace all of these with score.player. This is going to be score.cpu. And this is going to be score.ties. If we save that, okay, we got an issue here, probably because we're not passing the score from our game section here. So let's go ahead and pass that in. So score equal whatever the score state is. So that one that we've defined here, we're just basically passing it into our scoreboard. Let's save that, start the game, and here we go. Looks like there's an issue with the ties. Oh, because it's missing an S. Here we go. So now every time we actually play around, we're going to be calling this function. We're going to get whatever the CPU move is, decide the winner, update the score. Let's see if that works. So here we go. Looks like it is working. All right, if we look at our previous game, we also see that we have this history section. So what we need to do now is also update our history section, but we don't have one to begin with. So let's go ahead and create another state that will capture the history, set the history, and this will be by default an empty array of objects. Now, just for testing sake, I'm gonna go ahead and create one object here with the values that we're interested in, just so we can test out how our history section is gonna look like. So the history is gonna capture whatever the player move was. So in this case, let's say this was paper, whatever the CPU move was, CPU, let's say rock, and whatever the outcome was, or maybe whatever the message that we want to show the user is. So let's say if you pick paper, the CPU picked rock, then you win. And let's see, what would that look like? We'll take this object here, we're gonna find our history section, and we're gonna pass it on as a property. Then I'll go into the history section, and then here we're gonna capture the history object. And here inside of our unnumbered list, this is where we actually need to iterate over the array of objects that we have here. So here we go, we'll create an expression, history map over each item or each history item. I'll just call it H for now. And what we want to produce for each one of those is a return, or we can actually do it over one line like this. This will be a list item. Let's go back here just so we can see what it would look like. That list item is going to say the player picked history item dot player. Let's see, this probably will need to be wrapped like so, versus CPU, where the CPU's move was, actually let's go ahead and get rid of this curly bracket here, or this backtick here, and this is going to be h dot CPU, and then we'll have whatever the message is, so h dot message. We save, scroll back here, and there we go. We actually get our the hard-coded history object that we passed in, and it's populated right over here. Now it looks there's a bit of a distance between where the bullet point is and the rest of the text. We can fix that by basically updating our styles for our unnumbered list. So I could do style where I want the text align to be left, and here we go, that looks better. Now let's go back to our game section, because now when we play a round, not only are we going to be updating the score, but we also want to update the history. So we're going to set the history to be, let's capture whatever the current history is, and we're going to use that to basically append our new history record onto the existing one. So we don't want to be replacing or deleting anything that we have, we just need to be adding a new one. So here's the new object, player will be move. The CPU is going to be whatever the CPU move was. And then the message is, well, this is where we're going to calculate the message based on the outcome. Let me just copy this over from my previous project just so we don't have to repeat that work again. Here we go. Now our message is going to look for the outcome. If it says player, it will say you win. If the outcome was CPU, it will say CPU win. Otherwise, I'll just say tie. Now here we go. Only thing left to do is to spread the previous current history at the end. So basically what we're doing right now, every time we get a new history record, we're adding it on the top of the history list, and then we're appending the rest of the history onto that new array. So if I save this, and let me actually go ahead and remove this starter hard-coded value for our history record because we no longer need that. And now if I start playing, I'm updating the history and I'm also updating the scores at the same time. Maybe one more other kind of minute thing that we could do together. If I switch back to my app.jsx file and we scroll down to where the component is being rendered, or the return of the JSX component here, if we change this class name to theme dark, you notice how this actually toggles on our dark mode. So what we could do here to actually make this dynamic and make it respecting whatever the settings that the user is setting is basically capturing that whenever the dark mode changes. So what I could do is create another variable. I'll call this current theme. And this will be driven by whatever the dark mode value is. So if dark mode is true, then we want the theme to be called theme dark. Otherwise, we want it to be theme light. Now I can take this variable here, go into my class name, and I can replace it with an expression that basically uses this variable. So now if I save that, because the user has set the dark mode in their settings to be true, this is why we see it as dark. But if I come back over here and click on the dark theme, it'll automatically turn everything to light. Notice how this is actually being triggered now even before we hit the save button, because all what the save button actually does is that it saves it to the local storage. But because the dark mode property is actually a state that is being passed from the app component onto our lobby view, and the set dark mode is also being triggered inside the lobby, whenever we change those values, it's automatically updating everywhere. And with that, I think now you should be able to take this to the finish line with everything that we've talked about in last week and this week's videos. And good luck. Let me know if you have any questions.